Hey guys, this is Candice. Today I'll go through question 8 of the midterm exam review. Okay, so let's first read the question. Okay, Pecco, a dancing donkey with anger management issues, can contain his anger for an average of 10 minutes before directing a violent kick toward his handlers. Okay, assume that likelihood Pecco tries to kick his handler follows a Poisson process. Okay, so from the question we know that on average, okay, we see one kick every 10 minutes. Okay, and since the likelihood Pecco tries to kick his handler follows a Poisson process, okay, the occurrence of the event, okay, will follow a Poisson distribution with parameter equal to 1 over 10, which is on average the time of occurrence, okay, for each unit of time, which is minute. Okay, so let us first define the event, which is violent kick by the donkey toward his handler. Okay, then the event occurrence follows distribution in the case that the time between occurrences, or the time between the kicks by the donkey, actually follows exponential distribution with the same parameter, which is 1 over 10. Okay. Then we define a variable. We let x be the number of minutes before Pecco directs a violent kick. Okay, so as from the question, x follows exponential distribution, okay, with the parameter 1 over 10. Okay. Then for part A, suppose Pecco tries to kick his handlers right before his afternoon performance. What is the probability he will try to kick his handlers before the 20-minute performance is over? Okay. So we want to know the probability of the first kick happening within 20 minutes from the start of the performance. Okay, so the start of the performance is time 0. Okay, recall that x follows exponential distribution with parameter 1 over 10. Then from this PDF and CDF formula, we can derive the probability of x being less than little x, which is 1 minus e to the power of minus 1 over 10 times x. Then the probability he will try to kick his handlers before the 20-minute performance is over is equivalent to finding out the probability of x less than 20. And you simply plug 20 into the formula, okay, into the CDF formula to get 1 minus exponential of minus 1 over 10, the lambda, okay, times 20. Okay, so 1 minus e to the power of minus 2, which is 0.8647. Okay, then for part B, suppose Pecco last tried to kick his handlers 10 minutes ago. His 20-minute afternoon performance is about to start. What is the probability he will try to kick his handlers before the performance is over? Okay, to ease our understanding of this problem, we will first try to draw a performance timeline. Okay, so the first or the last kick actually occurred 10 minutes ago at time minus 10, and we are now at time 0. Okay, so we know that the time since last arrival is already greater than 10. Okay, then the question asks for the probability that the next kick occurs before time 20. Okay, so in 10 minutes before the performance, okay, plus 20 minutes of the performance, we'll get 30 minutes in total, and we will find out the probability of x less than 30. Okay, given the information of x is already greater than 10. Okay, so this is the conditional probability. Okay, then we apply Bayes' theorem. The numerator becomes the joint probability of x less than 30 and x greater than 10. Okay, so this will give you actually the probability of x being between 10 and 30. And the denominator is the probability of x greater than 10. So So recall that given the CDF of X, the probability of X being between A and B would be FB minus FA. Okay, so we apply the CDF formula for twice, okay, for 30 and 10 respectively, and get the difference between the two probabilities, and then divide it by, okay, the probability of X greater than 10. Okay, so the common term is exponential of minus 1 over 10 times 10. We cancel this out for the numerator and denominator, and you will get 1 minus e to the power of minus 2, which is 0.8647. Okay, exactly the same as part A. This is because that the arrival rate is independent under Poisson process. And these two questions is actually a twist of the problem set 1, question 4. Okay, then for the last part, okay, part C, handler Joe brags to the audience that Paco will try to game at least 4 times a day. Joe and Paco spent 40 minutes together that day. What is the probability that handler Joe is right? Okay, so we're back to the Poisson distribution or Poisson process. Okay, so from the question we knew that the number of occurrences follow a Poisson process with unit time arrival rate 1 over 10. And how many units of time we have in this part? We have 40 minutes. Okay, so if we define a variable y, okay, as the number of kicks in 40 minutes, then y will follow the Poisson distribution with parameter equal to, okay, the unit time arrival rate times the units of time, 1 over 10 times 40, which is equal to 4. Then the PDF of a Poisson distribution with parameter 4 will be, okay, by the formula will be e to the power of minus 4 times 4 to the power of y divided by y factorial. Okay. Okay, we want to find out the probability that handler Joe is right, which is equivalent to the probability of this y greater than or equal to 4, where his claim is actually right. Okay, then taking a complement of y being greater than 4 will make the calculation much easier. Okay, that involves 4 possibilities. Y is either equal to 0 or 1 or 2 or 3. Okay, then for each of the possibilities we'll apply the formula, okay, the PDF formula, and then sum the densities up, okay, and take out the common term, which is e to the power of minus 4, and sum up the terms in the brackets, okay, which will give you 71 over 3, and then, okay, do the calculation. At the end of the day, we'll have 0.5665. Okay, this is the probability of handler Joe will be kicked at least 4 times during the 40 minutes stay with Paco. Okay, so I think that's all for question 8. If you still have any questions, please feel free to send me an email.